In this video, we want to take a look at an example. Travel taxes. Travelers pay taxes for flying, car rentals, and hotels. The following data represent the total travel tax for a 3-day business trip in 8 randomly selected cities. A normal probability plot suggests the data could come from a population that's normally distributed. A box plot indicates there are no outliers. So we have 8 data values. In Part A, we want to determine a point estimate for the population mean travel tax, and B, we want to construct and interpret a 95% confidence interval for the mean tax paid for a 3-day business trip. Now, in order to construct this confidence interval, we need to make sure that the conditions are met in order to construct a confidence interval for a population mean. And so remember, those conditions are that the sample has to come from either a simple random sample or a randomized experiment. The sample size has to be small relative to the population size. In other words, the sample size has to be under 5% of the population. And the data has to come from a population that's normally distributed, or the sample size has to be large, meaning 30 or more. So notice in this case we have a sample of 8 data values. That doesn't meet the third condition of having a large sample. So we have to know that the data come from a population that's normally distributed. And so the problem statement tells us that a normal probability plot suggests that data came from a population that's normally distributed. We also have to worry about outliers, and so the problem statement tells us there are no outliers. If we weren't told those 2 statements in the last 2 sentences, then we would have to construct a probability plot to verify that these data come from a normal distribution, and we would have to construct a box plot to verify that there weren't any outliers. In this case, we were told, so we don't have to do that work. Now, as a general rule, if our sample size is 30 or more, then we wouldn't really worry about the normal probability plot part, because we would assume that we have a normal distribution if the sample size is 30 or more. So we want to determine a point estimate for the population mean, and we want to construct a 95% confidence interval. So the first thing that we're going to do is to find the point estimate for the population mean. So I'm going to bring in my calculator. I'm going to go to Stat and Edit, and I have already entered these 8 data values into list 1 in my calculator. So that's the first thing that we have to do when we're given data, is we have to enter the data into our calculator. Second, quit to go back to the home screen, and I'm going to calculate the point estimate, which is the sample mean. So to calculate the sample mean, I'm going to go to Stat and Calc, 1 variable statistics. My data is in list 1, so I'm just going to calculate that. And so X bar is 83.34875, and incidentally S is 12.3236354. So I'm going to write those down. To specifically answer Part A, X bar is equal to 83.34875. So on average, the travel taxes are about $83.35. So that would be the answer to Part A. If I round to the nearest penny, $83.35 would be the taxes for a 3-day business trip. Now, in Part B, I want to construct and interpret a 95% confidence interval. So in order to do that, I'm going to also need to calculate the margin of error. Well, remember our formula for calculating the margin of error is that E equals T sub alpha over 2 times S over the square root of N. Now I'm going to calculate this 3 different ways. One, I'm going to do it by hand now that I know my point estimate. I'm going to do the rest of the confidence interval by hand to demonstrate that. Then I'm going to show you how we could do this directly with the calculator. And then I'm also going to show you how we could do this in StatCrunch. So I'm going to show you 3 ways to do Part B. You don't have to do it 3 ways as a general rule. You can pick the one that you prefer. Now, in order to do this by hand, I need to figure out what is my critical number. Now recognize that the sample size here is 8 because we have 8 data values. We found the mean already, and we also found on the calculator that the standard deviation was 12.32363054. So when I found the mean, I also found that the sample standard deviation was 12.32363054. Now, so anyway, if my sample size is 8, that means we have 7 degrees of freedom, 8 minus 1. So to find this critical value, I have this t-distribution with 7 degrees of freedom. I'm doing a 95% confidence interval, so that means the area here in the middle is 0.95, which means the area in each tail is 0.025. Again, the total would be 0.05, and half of that goes in each tail. So I can figure out what this critical value is either by looking it up in the t-distribution table, by using the inverse t command on my calculator, or by using the t calculator in StatCrunch. I'm going to use the table. So I'm going to the column with 0.025, that's the area in the right tail, and I'm going down to 7 degrees of freedom. And so that critical value is 2.365. So this value here is 2.365, which means this one's negative 2.365. And so that's the value that I'm going to use here, is 2.365. So I have 2.365 times S. I don't want to round too short, so at least carry that out like 5 or 6 places. I'm going to just use the whole thing. So 12.3236354 divided by the square root of the sample size, which is 8. So if I bring back in my calculator, 2.365 times 12.3236354 divided by the square root of 8. And so that is about 10.3044512. So I'll go ahead and write that whole thing down. 10.3044512. So I know my point estimate is about $83.35. I know my margin of error is about $10.30 if I round to 2 places. So I'm going to carry it out maybe like 3 places and then round ultimately to 2 places. So this is going to be 83.349 if I round to 3 places here, minus 10.304 if I round to 3 places, and 83.349 plus 10.304 if I round to 3 places. So if I bring in my calculator, 83.349 minus 10.304, that is 73.045, and 83.349 plus 10.304, that is 93.653. So this would be 73.045 to 93.653. So if I round that to 2 places, that would be 73.05 to 93.65. So 73.05 to 93.65. And really that's dollars. So I am 95% confident that the true average travel tax for a 3-day business trip is somewhere between $73.05 and $93.65. So we've done this by hand. Now let me show you how to do this with the calculator and with StatCrunch. So if I want to just do this problem directly with the calculator, then I can go to Stat and Edit, and I can enter the data values into a list. So in this case, I've entered the data values into list 1. Once I have the data into a list, I can go to Stat and I can go to Tests. We want to do a t-interval. So if I choose option number 8, t-interval, then I have the option of data or statistics. Well, this time we have data. So I'm going to choose the data option for input. So if I choose that option, I just tell the calculator which list did I input the data. So I put the data in list 1, so I need to tell it that. Leave frequency at 1. The confidence level's 95%. And calculate. So it gives me the point estimate there, 83.34875, which is the same point estimate we've got before. It gives me the standard deviation, which is the same standard deviation we got before. And so it tells me 73.046 to 93.652 is the confidence interval. And so if we round to 2 places, that is 7305 to 9365, which is the same result that we obtained when we did it by hand. So again, when we have data such as this, we could go directly to the calculator, enter the data into one of the lists, and then use the data option when we do the t-interval. Now let's take a look at StatCrunch. Well, in StatCrunch, I have already entered the travel tax data into one of the columns of the StatCrunch spreadsheet. So you can either enter that in directly if you need to, or remember you can open the data in StatCrunch from homework. So if this is a homework problem, you could select the icon and open in StatCrunch in order to load the data into StatCrunch so that you don't have to actually type it. So I'm going to go to Stat, and I'm going to go to T-Stats. We have one sample, but this time we have data. So I'm going to choose with data. So when I make that option, what I have to tell StatCrunch is what column do I have the data in? And so I have the data in this column that I've labeled travel taxes. Once I enter that, I tell StatCrunch that I'm doing a confidence interval for mu, and I'm doing a 95% confidence interval for mu. If I say compute, then StatCrunch gives me the lower limit here, which is 73.05 if I round to 2 places, which is the same result we obtained by hand and with the calculator. And the upper limit is 93.65 if I round to 2 places, which again is the same result we obtained by hand and with the calculator. And also StatCrunch does give me the point estimate there, 83.35 is the sample mean as well. So it does give me that. It also tells me the degrees of freedom, 7, if we need to know that. So this is how we can calculate using StatCrunch when we have data. So we have constructed the 95% confidence interval for the mean tax paid for the 3-day business trip. We're also supposed to interpret that. I did make the statement, we are 95% confident that the true travel tax for a 3-day business trip, we are 95% confident that the true mean travel tax for a 3-day business trip is somewhere between $73.05 and $93.65.